Hello everyone. Today we're continuing with factoring quadratics, and this time we're going to be factoring quadratics that also have a GCF. So let's go ahead and see how this works. So when factoring quadratics, you always want to check if there is a GCF to make the problem easier to factor. Now, this means that if you have a GCF, it means you will be factoring twice. Once when you're factoring out the GCF, and the second time when you factor it into two binomials. So you will end up with three factors. So it will look something like this: your GCF, the first factor, and then the second factor. So it looks something similar to this right here. So three factors, 1, 2, 3. All right, let's go ahead and start with number 1. So we can just factor regular, but notice that we have pretty big numbers here. So factoring a GCF will usually make the problem a lot easier because it will make the number smaller that we are going to work with for the second factoring. So let's go ahead and start this one. So we're going to start off by checking that they all have a GCF. All numbers have a GCF that we can factor out. So these are all multiples of 8. This is 8 times 6, 8 times 1, of course, and 8 times 16. So we have our GCF being 8, so I'm going to put my 8 on the outside. I have my v squared still. I bring down my plus sign. I still have a v here and a 6. So we have 6v. And then here we have our minus sign, and we still have the 16. So this has been factored. The numbers have become much smaller, so they're going to be a lot easier to work with. So now I'm going to go ahead and do my x factor. And luckily here I can use the shortcuts because that's an invisible one. So let's go ahead and do our x factor. We have negative 16v squared and 6v at the bottom. So we were looking for two numbers that multiply to 16 and combine to give us positive 6. In this case, if they subtract, answer will be 8 times negative 2. So now again, I can use a shortcut. So I'm going to write this out. I know my variable is v, so it's going to be v plus 8 from the left side, and v plus negative 2, or v minus 2, from the solution on the right side. So again, using this shortcut. The only thing we have to be very, very careful about is to not forget our GCF. The GCF is part of our final solution because it's part of the original polynomial here. So we make sure to not forget to put the 8 up front. So this 8 is part of our final answer, and it's in the front. So it's 8 times 2 more factors, v plus 8, v minus 2. So there are 3 factors. We split them once, we split it a second time. Let's go ahead and move on to number 2. So again, we notice the numbers are rather large here. Again, we are going to have a GCF. These are all multiples of 6. So we're going to go ahead and factor out a 6. So 6 times x squared. And actually, before I write it down, let's write down the factors. This is 6 times x squared, or 1x squared, 6 times 8, and 6 times 15. I'm going to go ahead and factor it now. We can factor out a 6. We're left with x squared minus 8x plus 15. So now I'm going to take the factor inside, not the 6, the factor inside of the parentheses. I'm going to factor it out. Again, I can use the shortcut because there is a 1 right there. So I'm going to do my x factor. 1x squared times 15 is 15x squared. 8x at the bottom. Two numbers that multiply to 15 and add to 8 would be 3x and 5x. I'm going to use my shortcut because I have a 1x squared at the front of this polynomial. My variables are x. My first number is 3, so plus 3. My second number is 5, so I'm going to put plus 5 using my shortcut. And then, again, I do not want to forget my number at the front, my GCF. So my answer is 6 times x plus 3 times x plus 5. Let's go ahead and move on to the next one. Again, we have another one where it doesn't look quite like the ones we're used to. We have a k cubed, we have a k squared, and a k. But we should notice they all have a k in common. They're also all multiples of 5. So again, we have 5 times 5 and 3 k's. We have 5 times 16 and 2 k's, and we have 5 times 12 and a single k. So we have a 5k in common in all of these. So we have 5 and a k in common. So that's going to be my GCF, 5k. And I write down what's left over, 5k squared for the first one, 16k for the next one, and positive 12 for the last one. Now in this case, I will not be able to use a shortcut because we have a 5 there. So in this case, we have a GCF, but we still have to do the X factor and the box to factor it all the way through. So again, no shortcut in this case. So let's go ahead and start with our X factor. We have 5 times 12 is 60, k squared. Middle term goes at the bottom, 16k. Two numbers that multiply to 60 and add to 16 would be 10 times 6. And we put k's on each one. So now we're going to go ahead and do our box because, again, we cannot use a shortcut because of that 5 up front of the polynomial here. So again, first term goes in the first box. Last term goes in the last box. Middle term gets split by these two. So we get 10k and 6k. Then we go ahead and factor it out. What do 5 and 10 have in common? A 5 and a k. I need a k at the top to get 5k squared. 5 times 2 is 10k. And 6 times k gives me the 6k. And then I check this 12 at the very end. Is 2 times 6 going to give me 12? Yes, it works out. So now I'm going to write out my two factors. 5k plus 6 and k plus 2. And I want to make sure I do not forget my GCF. Again, don't forget that. So my GCF comes down here, and it's a 5k. So the GCF and the two factors from the box. So that's the general idea of how we do it. So again, we know this process for each one. We're just adding the extra piece of a GCF. So go ahead and try 4 and 5, and then come back and check your work. So go ahead and pause your video. All right, for number 4, you should have factored out that 2 as your GCF, and then you should notice you can use the shortcut. So let's see what we get with our shortcut. We get the following. You should have gotten 7 times 2, no, 6 times 3. So n plus 6 and n plus 3. And don't forget your number up front. And that's pretty much your answer for number 4. Factor out the 2, then X factor shortcut. Let's look at number 5. So on number 5, you should have factored out a 3. So we have negative 15n squared at the top. We have negative 2n at the bottom. We can use our shortcut here. Again, we have that 1, which is a good thing for us. So two numbers that multiply to 15 and subtract to negative 2 or combine to negative 2, 5 times 3, where the negative is the 5. So we get our shortcut n minus 5 and n plus 3. And once again, do not forget the number or the GCF that goes up front, which is a 3. And that's pretty much the idea. Go ahead and factor out a GCF if there is a GCF. Then X factor, whether it's a shortcut or the box. All right, go ahead and start your practice, and good luck.